Hey, hello, how are you? So I continue working on my Markdown slash JSON logic, and I've made some progress actually. I've added like a plus operator, so the um, plus node accepts some values and it adds one to one here, and it equals to 2. So that's cool. And while I was doing that, or thinking about that, I came across a interesting an interesting idea that in my original. Let's go through this first. So when I am getting a list of my all combined things, I actually do get a list of nodes that are essentially, you know, let's look at this. A list of possible operations like here, or just an operation, or some sort of primitive, right? And the primitive is just a JSON surveys value, which could be a number, it could be a string, it could be an object of all mentioned things above. And that led me to think that in my original implementation of the expression evaluation, I experimented way too much before, and I was implementing my very own operand number and operand string, etc. And this was way too much. So I actually refactored my previous expression evaluation thing into using just JSON surveys value as a number. And the design choice I made is that my JSON context should only receive floating point numbers because, well, JSON survey makes clear distinction that the number is either floating point or integer, and since handling those differences is way too much, I am going to make it explicit that I want to work with floating points, just because I want to use all of this in a game at some point. So back to the plus operator way down below. So for plus operator, where is it? Yeah, there's different things that could happen when I get my list of parsed items for the plus operator. I should actually check what the hell am I getting. If I do get two numbers, then I read them as floating point numbers, 2, and yeah, I sum them up, and I have to return another primitive of a type number from floating point, and I know for sure it works because all the numbers are provided with default values if the SF64 method of a number kind of fails. And also, if I do get a string, then yeah, I should be able to concatenate two strings with a format, a standard format function from Rust. And as you can see, this is kind of similar to what I had in my executor thing. Yeah, this stuff. But I had some weird plus operators, whatever. So now, actually, with this, I want to add a minus operator. So let me add this one here. So for minus operator, I don't have it yet. 2 minus 1 should be equal to 1. And of course, if I try to run it, it's not going to give me a correct test outcome, mainly because I don't have this yet. So I have to add another one, another operations alias for a minus. All right. Actually, let me hide my face because it is is just in the way. Whoop. Where is it? Movie recording. Yeah, hide it. All right. So now, obviously, Rust is yelling that my match statement is not exhaustive. And for minus operation, I'm not going to support string concatenation. Like, how do you remove a string from a string? I don't want to do that. This is not the point of all this, actually. So I'm doing the very same thing. I'm getting a binary operation var list, which is basically a handy function for me that for binary operation I need to have a list of 2 at least. If it doesn't give me anything, I don't return anything. If it has a list of things in there, I execute combined list thing I have, and I get literally 2 items in the list, finalized values of items. So for my minus operation, where is that? So there's my minus. So the section with string processing, I am just gonna remove that. In case if I'm not getting numbers, then I'm just gonna return null because, well, this is not a very permissive configuration I'm building. And all this is going to do is just subtract, sorry. So again, reading the same primitives as JSON Surday's value. It's supposed to be a number. I get referenced or borrow those. I unwrap them as floating point. Variables, and get the result as this res thing. And eventually I create another number, JSON Surday's number, from floating point. I get unwrap. I know for sure this is going to be an actual number. Yep. And this way, when the thing is built, I know for a fact that the outcome of this thing will be able to be serialized back into JSON. So now, since I copy pasted that, and apparently there's no errors, let us try and run it, and hopefully it passes now. It passes because, well, it works. So now I have a minus operation. Actually, since we are at it, let's go ahead and create the same multiply. Oh, no. Multiply operation, where I will be checking if 2 times 3 is 6. So we don't have multiplication yet. Again, since my node setup is pretty much done, I can just multiply. All right. Now again, this thing is yelling at me that the match statement is not exhaustive, and I can copy paste this stuff again. This is quite mouthful for all the logic I have here. I mean, there's quite a lot of copy pasting happening, but this is, well, it's going to be quite performant, I believe. So all I changed here is just, yeah, multiply. And again, multiplying some nonsense will still result into JSON third days null representation as a value. It's going to be serialized in my enum as was planned. And if I run my test again, it passes. And let me quickly add division as well. So if I want to divide 6 by 3, it should be 2. Yeah, let's have division. This is going to be an interesting one, mainly because I want to take into account that division by 0 is not permitted. And if there's division by 0, I'm just going to return null. I don't want to introduce any infinity variables for my numbers. So this is the dangerous part. So let me read second parameter. Let second equals to all that. And if second equals to 0, then I'm going to return immediately this, because I don't want to handle like infinity, right? Division by 0 usually results into infinity number. And otherwise, if division by 0 is not, oh no, wait, if the second parameter is not 0, then it's gonna just work as previously in those examples. And yeah, let's run it. Still passes. All right, and just for the sake of testing, when my division by 0 happens, this is supposed to be null. I wonder if this works. Actually, with all the years of experience with JSON and JavaScript. I haven't written null specifically in JSON. Yeah, let's try it. Still works. Nice. So this is that. So let me briefly say why all this is important now. I've been thinking about my executor for postfix representation of a function that I might have. So if you have seen my previous sessions, I was able to interpret a simple function like expression. So 20 is not equal to 20, it's supposed to be Boolean false, that's fine. And I was executing all this with a stack. So I push 20 on a stack, I push another 20 on a stack, then on the top I would push an operator. And when I was reaching the operator, I would pop 2 items from stack, like 20 and another 20, and I would perform operation, and I would put push the result of the operation on the stack again. So this is quite a lot of code for like stack manipulation, actually. And I'm thinking that my postfix representation of a function or expressions that I had could result eventually into JsonLogic's representation, mainly because JsonLogic is like a abstract syntax tree which I was envisioning in the very beginning, but I wasn't sure how to make it work, not efficiently, but in general. And the postfix things that I already have, that I receive in the interpret function, it actually has all the necessary checks needed to build JsonLogic's abstract syntax tree. I could take it, I could scan it, I could reach some sort of operator like I have in here, and when I reach an operator, I would in the same manner pop 2 items, and I would create JsonLogic's operator with 2 items in there and perform operation in one place with all this kind of simple and direct logic that I have in here. So hopefully I didn't bore you too much, and see you next time.